Hello, welcome back to quadratic word problems. Okay, we are going to start with how to set up the first one. And then we are going to go on. So what I'm going to do is I'm going to go through this and I'm going to just set these up and explain how I'm setting them up. All right? So first off, we have two real numbers, so x and y are in R, such that their product, x times y, is a max, and their sum, x plus y, equals s. Now, I know I'm making my s's a little funky, but that is so that it doesn't look like a 2 or 5 or something like that. And we also know that s is a constant. And it's a constant real number, okay? It's a constant in R. All right? Now, since x plus y equals s, we know that y equals s minus x. So then we're going to have the function f of x equals x times s minus x, which means that we have minus x squared plus sx. We also know that for the max of a quadratic, that if we have ax squared plus bx plus c equal to f of x, then our max slash min occurs at x equal to negative b over 2a. So what we're going to do is we're going to find the point x equals negative b over 2a. In our case, b equals s and a equals negative 1. So that's negative s over 2 times negative 1. So that gives us s over 2. Okay, so if x is s over 2, then y equals s minus s over 2. So that's 2s over 2 minus s over 2, which is s over 2. Now, I want to be complete in my answer, so I'm going to actually find out what that maximum is. So what is f of s over 2? So that's going to be negative s squared over 2 squared minus s over s times s over 2. So that equals negative s squared over 4 minus s squared over 2. If I get an LCD, why am I not getting a positive? Because this should have been a plus right here. So then this is a plus. That's better. So that's minus s squared over 4 plus 2 s squared over 4. So my answer is s squared over 4. All right. Now let's write our complete sentence. The two numbers are s over 2 and s over 2. That is, or i.e., the sum divided by 2. And the max will be the sum squared divided by 4. All right? Okay? Now let's go look at the next question. So the next question says, find two positive real numbers. So that tells me x and y are real numbers where their product is a maximum. So x times y equals a max. And the sum of the first, so x plus 3y equals 30. So if I have x plus 3y equals 30, then I know 3y equals minus x plus 30. So y equals minus 1/3 x plus 10. So then f of x equals x times minus 1/3 x plus 10. So f of x equals minus 1/3 x squared plus 10x. Now for my max, I know that my x value has to be equal to negative b over 2a. So b equals 10 and a equals negative 1/3. So that's negative 10 over 2 times negative 1/3. So that's negative 10 over 1 times, I'm going to flip the second one. So that's negative 3/2. So this gives me positive 15. Going back to here, if y equals negative 1/3 times 15 plus 10, then I get y equals negative 5 plus 10. So y equals 5. Going back here, if I find f of 15, then I get negative 1/3 times, holy cow, I really don't want to have to find that out. So what I'm going to do is I'm going to do it here. 15 times negative 1/3 times 15 plus 10. So that is 15 times 5. Ooh, I can calculate that a lot easier. So 15 times 5 is 75. Yay! The two numbers are 5 and 15 with a max of 75. Okay? Now let's go to the last one. Now this is a physics word problem. Okay? The easiest way is for us to do this with technology. So that's what we're going to do. I'm going to save this so that I'm not writing on the board. I'm going to go out here, go to Wolfram Alpha, and I'm going to go right here. I'm going to tell it to plot y equals negative parentheses 16 divided by 2025 and parentheses 16 divided by, let's just start over, 2025, close parentheses, and then I have x squared plus parentheses 9 divided by 5 close parentheses x plus 3 divided by 2. And that plus did not take plus. And I'm just going to go ahead and do 3 divided by 2. All right. Then I'm going to hit the equal sign and tell it to graph. And then you put the graph down on your paper. And if I hit properties, it tells me the maximum. And the y-intercept and it tells me okay, so let's go back now to our piece of paper. So part A. How high is the ball graphed? All right, so what it gave me was it gave me this graph, right? And it said this was x, y, and it said this was 200 and this was 250. Now I'm going to go back over here and I'm going to look at it again. All right. Now I'm going to go back down here and it tells me my vertex is 113 and 104.16. With a vertex is 113.906, 104.016. All right. Then it tells me, then I need to go back and I need to find the x-intercepts. So I'm going to go back over here, and none of this information is my x-intercepts. So I'm going to go back here and I'm going to say, find x-intercepts. Okay, and I want approximate forms. Okay, so there are the approximate forms. And now I'm going to go back and I'm going to write them down. Negative 8.303 and x equals 228.6. And then for the y-intercept, I don't need to look over there because all I have to do is I need to put 0 in. So for the y-intercept, if I put 0 in, I get this is 0, and I get 3 halves. So I get y equals 3 halves, which is 1.5. All right, so now I'm going to write my answers in complete sentences. So for part A, it says, the question says, how high is the ball when it is punted? The ball is, and the maximum height is the top of the vertex. So the maximum height is this point up here, is this point right here. So that's going to be the y value of my vertex. So the ball was, how high was it punted? So that it started out right here. The ball was 1.5 feet off the field when it was punted. All right, part B. What is the maximum height of the punt? So the maximum height of the punt was 104 feet. The maximum height of the punt was 104.016 feet at 113.906 feet from the start of the punt. And part C says the punt, how long was the punt? The punt hit the ground at 228.6 feet. Okay? Nope. Right? That's all I have. Please email me if you have any questions. Thank you.